Hello everyone, welcome to Algebra 1, Lesson 77. We're talking about scientific notation today. We've already studied scientific notation, so this is nothing new to you. We haven't really talked about it this year, but we have studied it before. Remember that scientific notation is a shorter way of writing really big numbers. Now the numbers that we work with right now won't be super big because they're just for you to practice how you write these numbers. So there's a rule. When you're doing scientific notation, look at this number right here. I have 4.16 times 10 to the positive b. When your exponent is positive, that means that that decimal point is really that many places to the right towards positive numbers on a number line. When your exponent is negative, that means your true decimal point is really that many places to the left, so towards negative numbers. So that helps us determine how to go from scientific notation to regular numbers and backwards from regular numbers to scientific notation. So let's practice. Look at this one, 0.000416. There's a two-step process. So first, to turn a number into scientific notation, you have to put your decimal point right behind the first non-zero digit that you come to, reading from left to right. So going towards the right, the first non-zero digit, which here is 4. So I have 4.16. Now you say times 10, because we've moved our decimal point, so we know that our decimal means that we're multiplying by 10 in order to, or dividing by 10, in order to get that decimal to where we want it to go. Now, we've moved it 1, 2, 3, 4, 5 places over. So our exponent is 5. Now, should it be positive or negative? Well, our real exponent, is it really 5 places from here? Is it really 5 places to the right? Or is it really 5 places to the left? It's to the left, so our exponent has to be negative. So 4.16 times 10 to the negative 5. It might be hard for you to see, so let me write that again. Negative, still hard to see, but negative 5, okay? All right, let's try this one. 4.165 times 10 to the 7th. This one is written in scientific notation, so I want to write it as it really should be written. So since I have a positive 7, that means that my real decimal point is located 7 places to the right. So I have 4, now 1, 6, 5, that's 1, 2, 3 places, 4, 5, 6, 7. So I fill the rest with zeros. And I put my commas where they need to go. 1, 2, 3, comma, 1, 2, 3, comma. All right, let's try this one. 714,600,000. I want to change this into scientific notation. Well, I have to put my decimal point right behind the first non-zero digit that I come to, which is 7. So it changes to 7.146. Now I don't write the zeros, I drop those off. Times 10 to the, well, I have 1, 2, 3, 4, 5, 6, 7, 8 places that I moved it. I moved it from here all the way to here. So 8 places that I moved it. Now I have to decide, should my exponent be positive or negative? Well, this real decimal point belongs to the right, 8 places to the right. So I leave it as positive. Okay, let's try another one, 0.000316. Well, to write in scientific notation, I have to write it right here behind the first non-zero digit. So it becomes 3.16 times 10 to the, well, I moved it 1, 2, 3, 4 places. Now, my real decimal point, does it belong to the left or does it belong to the right? It belongs to the left, so I make my exponent negative. All right, now let's try this one. I have the same number, 0.00316, but I already have times 10 to the 7th. So I need to further make it in scientific notation. I'm going to follow the same process. I go to the right of my first non-zero digit, so I put my punto in the same place, 3.16 times 10 to the, well, here I moved it 1, 2, 3, 4 places again. Now, I moved it 4 places to the left. So that would be negative, or it should go 4 places to the left, excuse me. So that's negative 4. But I already have a 10 to the negative 7. So this is plus that 10 to the negative 7 that I already have. So I have, or I should say it's times that 10 to the negative 7 that I already have, which means I add my exponents, negative 4 plus negative 7, to give me a negative 11, because I moved it a further negative 4, so it's negative 11. Let's try another one like that. Okay, this is the same problem, except this time my exponent is positive. So once again, I'm going to move my decimal point behind the first non-zero digit. So it's 3.16 times 10 to the, well, I moved it this many places. It really belongs 4 places to the left. So it's a negative 4. So I combine that negative 4 with a positive 7. Negative 4 plus 7 is a positive 3. So my final answer is 3.16 times 10 to the positive 3. All right, let's keep practicing. 47,800. I'm going to put my decimal point directly to the right of the first non-zero digit, so right after that 4. So I have 4.78 times 10 to the, I moved it 1, 2, 3, 4 places. My real decimal point belongs 4 places to the right. So I have a positive 4 as my exponent. Okay, now using this, I'm going to do the other ones. So again, my exponent goes in the same place, 4.78 times 10 to the, well, I already have 10 to the negative 7. I have 10 to the positive 4 here because my decimal point belongs 4 places to the right. So positive 4 plus the negative 7 that I already have, negative 3. Okay, here I have a positive 7. So it becomes 4.78, because I moved my decimal point right here. My real decimal point belongs 4 places to the right. So positive 4 plus the positive 7 I already have is times 10 to the positive 11. All right, pause your video and try your practice. Okay, letter A, you should have 4.99 times 10 to the positive 4. Letter B, you should have 4.99 times 10 to the negative 7. Letter D, or excuse me, letter C, don't know where D came from. You should have 4.99 times 10 to the negative 4. Okay, let me know if you need any help with those problems. Have a great day, guys. Bye.